Okay. Next topic is of digital recording. We already come across with many recording types where we are going to record the information based on different types. Here one more type where nowadays we will be preferring for a digital data are going to be recorded for a long duration. Okay, when we go to previous recording types where we are going to record the information in terms of your papers by using of a pens. We know that the life of those papers where we are recorded by the pens, there it's not been some after some interval, some of the periods it will be damaging due to some environmental accessing process. It will be changing of the information. You will not be able to get the what's the recorded information on the paper, right? For that reason we shifted for the one more type of recording, that is of a digital recording where we can record the information in terms of a digital values for the longer duration. Okay, in this digital recording, the main purpose is of store the information for the longer duration. In the an analog signal is going to be converted to the digital in our digital recording by using of an analog digital converter, which measures the amplitude of an analog signal at regular intervals of time, which are specified by the name, that is of the sample rate, and then stores these sampled and quantized numerical values in the computer hardware such as your compact disc and hard disk, pen drives, etc. Then a digital recording are very accurate. The accuracy is going to be determined based on the quality of unlocked digital converter and digital to unlocked digital converters. Based on the converters, is the converter operating in a proper fashion? What is the accuracy of that? Based on that, we can telling that what is the accuracy of the digitized data. Then, for optical disc recording techniques such as your CDs or DVDs, a laser is going to be used to burn the microscopic holes into the dye layer for the medium so that I can read the information. Then a weaker laser is going to be used to read the signal. This works based on the principle about metallic substrate of the disc is going to be a reflective, and the unburned dye prevents the reflection while the holes in the dye permits it, allowing digital data to be represented. This is how a small operation is going to be done when you are going to storing and retrieving the information from the DVDs as CDs. Then here a small example how a digital information is going to be taken from the analog. During the digital recording of a analog signal, analog to digital conversion takes place from a continuous time amplitude coordinators to the discrete time amplitude coordinators. Here a small graph is given where we are going to convert from analog. This whole continuous signal is of a analog, and the dotted lines what you hear is going to be, it is of a digitized data. Okay, from an analog we are going to convert to the digital values. These digital values, based on some filtering operation, we will check which samples we have to take and which sample we are going to be storing further. Okay, here the graph is drawn across your time and amplitude. The maximum voltage what we are going to be taking, here it is taken as Vmax, and here the point what is shown, it is of a DC offset, and this is of a signal, and this what's the V maximum or else a hard clipping if this level is going to be exceeded. If here a signal is going to be exceeding on it, we are not going to consider of this information. That's how a digital recording where we are going to convert from analog to a digital values. Here a small example it's taken where we are going to preferring from our mic to the sounding system. We'll be giving an input, a speech signal, That speech signal is going to be filtered by using of a filter. After filter operation, a analog to digital converter where it is going to convert from analog to a digital values that is given to the processing or storage. After a storage operation, it's given for the digital to analog conversion. From the DAC, again it's given for the filter, and then you will be listening of the input what you already given through a microphone. Okay, this is a clock where it is going to be based on the frequency, what in what way all the three should work, that is ADC, DAC, and also of a storage purpose. Based on clock, it's going to be operating. This is one example. One more example, pulse width modulation, how it is taken here. A multiplexer used, then modulator, then record amplifier, then magnetic tape is used. The input is going to be stored in the magnetic tape. Then reproducer amplifier it is going to be used. Then demodulator is used, and the demultiplexer is used. What is the input signal it is given? That is sampled. Again, here it is modulated by using of the amplifier. A signal is going to be recorded here. Again, coming back to the your digital values, again the samples, and again you'll be getting of your analog signal. This is about pulse duration modulation recognition system. Next, we'll go with the topic that is about ECG. In nowadays, in our biomedical applications, ECG, that is electrocardiographic, it's playing a crucial role. It is important role. From this, we can recognize what is the problem, what is the disease is there for a human. Okay, some based on the heart rate, will be determining what may be the problem the patient is having. That's what we are going to recognize by using of our ECG. Now we'll go into what is how it is going to be recorded, because we are going to dealing with the only for the recording system. We're not going in depth of what is ECG, how it is going to be measured, what may be the value for it is. We're not going to be taking that much about in depth of the knowledge. Just we will be what are the instruments we are going to be used, how it is going to be recording. Okay, an instrument which used to record the electrical activity. Observe here, we are going to measure the information in terms of a electrical activity of a heart. Okay, our body, what it's going for, it is in terms of electric only, in terms of your charge, how it is going to be flowing the information from brain to the whole body, right? The same information we are going to extracting that and telling that this is what happening for the body, right? That is about electrical activity of the heart is known as the electrocardiograph. The electrical signal generated by the heart activity are observed order-wise important than the mechanical functioning of the heart. It is very important to monitor the electrical signal of the heart using the electrocardiograph. Then it is possible to get the useful information about the cardiac disorders, which is mainly dealing with the heart. Then what is the block diagram it is consisting of? First, we are going a persons will be fixing the electrodes, ECG electrodes we call those. From the ECG electrodes, it's connected for the lead selector and a buffer. Then a preamplifier it is used. For the preamplifier, an input is of given as auxiliary circuit, and again charge transport motor is connected. Then preamplifier to the power amplifier. Then after power amplifier, bridge circuitry is used. From this, a feedback network is given. Then recording unit or a pen motor is going to be used. Now we'll go with the how a operation is going to be done by using of this machine. First, ECG electrodes are sticked to the body. The sticking is done as like this. A body, the electrodes are going to be sticked for the human. Body of the patient at a specific point. The signal sensed by the electrodes is then brought up lead selector switch. That is about lead selector. It's going to be taking. Then according to the pattern selected, which pattern you are going to be selecting, based on that, the signal is inputted to the pre-amplifier. It's going to be given to the pre-amplifier. Then, which is usually differential amplifier type. Here we are going to be using of differential amplifier type. This amplifier is provided with the high negative current, feedback to stabilize the output. After pre-amplifier, the signal is fed to the power amplifier. After this, it's given for the power amplifier. Most commonly, a push-pull type differential amplifier is going to be used in power amplifier. Here it is preferring for push-pull amplifier. Okay. One of the inputs is connected to the pre-amplifier output, which is unsymmetrically in nature. Other input is connected to the signal from frequency selective feedback network. From this, it's going to be connecting here, which is due to the change in the pen position. The output of the power amplifier is connected to the pen motor. It's connected to the pen motor, which drives pen during the recording. During the change in the position of the lead switch, the amplifier should be blocked. Hence, this can be achieved through the auxiliary circuit. The blocking operation is going to be done by using of this auxiliary circuit. And this circuit is used to provide the calibration of signal of 1 millivolts. Then the electrocardiogram is recorded on the graph paper with time measurement and heart rate measurement on the horizontal axis, while the amplitude of the signal on the vertical axis. Here an example where it is taken. Observe here the heart rate for the normal is a signal, where from here the condition in our electrical term we will be telling as RPS signal. Okay, here the one peak value to the another peak value, what is the interval is going for, based on the box of a graph we will be counting that. That is we call as RR interval. Here is taken as 4 large squares. The heart rate is going to be measured as 300. That's going to be divided with the number of large squares in the 1 RR interval. Here it is 1 for one peak to another peak, it is of a 4. Therefore, 300 divided by 4 is going to be 75 beats per minute. For the heart rate, how many times it's going to be beating. But based on that, we'll be recognized. This is the normal person's beat rate. Okay, this is how AC signal is going to be working on. Then the features of ECG machine is going to be taken as, the first one is of basically electrical signal generated by the heart are vector quantities, but during measurement only the scalar quantities are going to be measured in the form of the voltage difference. And the second one is of the frequency range needed for correct diagnosis is of 0.05 to 150 Hertz. By using of the advanced differential amplifiers, interference is minimized with the high CMR value of typically it's going to be taken as 100 to 150 dB. Then a notch filter is used with a notch of 50 Hertz so that AC means interference is reduced. It's going to be reduced. And the fifth one is of the preamplifier provides a large negative feedback. Preamplifier going to give a large negative feedback to stabilize the output. Also, the push-pull type power amplifier gives the single-ended output which drives the pen motor to move the pen arm. The sixth one is going to be the auxiliary circuit provides the calibration of signal of 1 millivolts and it blocks the amplifier during the changes in the lead switch. Auxiliary circuit is going to be blocking of the preamplifier till our signal where it is recorded, it has to be represent on the sheet, right? For that reason. Then the ECG machine provides a stand-alone mode during which the gain and baseline position adjustments can be done through without paper wastage. This from this we are not going to waste paper. The standalone function is going to be taken a operation so that will not use of wastage purpose is going to. Then the last one is of the sensitivity selected on ECG machine is typically 10 millimeter per millivolts. These are the features and about working of a ECG machine.